All right, I'm only going to work a few more examples today, and we're going to hit this a little bit more tomorrow. Okay, so cotan, the derivative of cotan, it's the derivative of a trig function that starts with the letter C, so we know it's negative. So it's going to be negative, and you know your chain rule is going to apply because it's not just x in there. Well, derivative of cotan is cosecant, so this is going to be cosecant squared. Keep your inside pure of 2x, and the derivative of the inside is 2. Okay, that can be rewritten as negative 2 parentheses cosecant, I don't know what I was doing there, cosecant of 2x squared, which is the way you really need to rewrite it if you want to take the second derivative of that. So I'm going to take the second derivative, I'm going to do the power rule, so that's going to be negative 4. My inside is going to stay pure, cosecant x 2x, and then my power, I'm just going to throw the 1 there just for you to recognize it reduced my power by 1. And then I need to multiply that by the derivative of the inside. Well, the derivative of the inside is going to be, I'm going to deal with this inside first, is going to be negative cosecant x, cosecant 2x, cotan 2x, and then I have an additional inside, so I'm going to multiply by the derivative of that, which is 2. And then I'm going to clean that up. I've got a negative here, that's going to turn the whole function positive. The 2 and the 4 can interact, becoming 8. And then when I look at that, I have cosecant 2x, this is not supposed to have an x there, cosecant of 2x, I have that 2 times. So I'm going to go ahead and call that cosecant squared of 2x, and then cotan 2x. Okay, I'm going to do example number 7. I'm hoping you might be trying at least some of these on your own. Obviously have a whole lot of stuff going on. I'm not doing the y prime yet. I'm rewriting this. This is equal to, it's much easier to see that this is a power rule problem when you write this as secant of 2x to the 4th quantity cubed. I do want you to try this one on your own, so go ahead and hit pause on the video and try this on your own. It is a function within a function within a function, and it's a good one to practice on. Okay, so my power rule says it's going to be 3. Keep my inside pure. Reduce the power by 1. Now I need to start taking the derivative of the inside. So the first thing I'm going to deal with is the secant. So the derivative of secant is going to be secant of whatever, tangent of whatever. And then I'm going to deal with the derivative of the inside, which is going to be 8x cubed. Okay, I'm going to clean that up as an answer. That'll be 24x cubed. And then I actually have secant squared of the 2x to the 4th and another secant, so I actually have 3 of those. And then I have just 1 of the tangents. Okay, I'm going to show you one more example of just a combination of things. This page, we've already done that one. We're not going to do this one today. So actually just going to go in here and add a page. I'm going to say, what if we have a function that looks like x square root of 2x minus 3? Okay. there are a couple of different ways to work this. Okay, I can do the product rule. This is equal to x times 2x minus 3 to the 1/2. And my product rule is going to say my first times the derivative of the second, which will be 1/2 2x minus 3 to the negative 1/2 times the derivative of the inside, which will be 2, plus, that's the first times the derivative of the second, plus the second times the derivative of the first, which is just going to be 1. Okay, and this is kind of a pain to simplify. That is the derivative. That works. But I could have also turned this into this particular function, the x. You can square it and put it back up underneath, and that's going to give you 2x cubed minus 3x squared to the 1/2. And that's much simpler to take the derivative of using the chain rule, because it's going to be 1/2 2x cubed minus 3x squared to the negative 1/2, and then multiply that by the derivative of the inside, which is going to be 6x squared minus 6x. And if you're going to end up with fractions here, if you combine like terms, get common denominators for your fractions, they'll simplify to be the same thing.